Good morning, everyone. Today, in software architecture, we are going to learn about architecture, implementation, and testing. In the previous classes, we studied about the requirements and design. And in this class, we are going to learn about the implementation and testing. Here, we are going to learn about architecture and implementation, architecture and testing, and what we are going to study will be in the summary. Okay, first one, architecture and implementation. We have the according to the requirements and design, we have the architecture. Okay, so this architecture should be the consistent one. To implement this, we are using four different techniques. First one is the embedding the design in the code. Second one is the frameworks. Third one is the code templates. And the fourth one is the keeping the code and architecture consistent. Means avoiding architecture erosion. Erosion is nothing but the design put the architecture should not be changed. Okay, that is known as consistent. Okay, first we are going to see the first technique, that is embedding the design in the code. Embedding is nothing but combining. Okay, so this architecture is the blueprint for the implementation. So implementers must know what the structure will be. For example, either it is a layer structure or a subordinate structure or MCV or broker. So that particular structure has to be identified by the implementers. Then, according to the architecture structure, there should be the codes. The code should be with the comments, so that anyone who is going to pick the code in the future should understand about the constraints. Next one is the conventions about how to do this particular one. So according to the structure architecture, the project should have the conventions. Then only the tools will automatically relate that code and the architecture. So that is called as the embedding the design in the code. Okay. So there is a code. In that code, there is going to be a command and the structure which is going to tell about the system. Next one is the frameworks. It is a reusable set of classes. According to the organization, it can be the special theme. So the programmer will be using variety of services provided by the network. For example, in MVC, Ruby on Rails is the base of the design in the web application, and it will gather the information about the web server, and it will take those informations to the databases, and it will render the templates. So the AutoSOAR is designed for the computers inside the automobiles. Next one is the code templates. Code template is a collection of code within the programmer provides a specific portions of the code applications. So the example is failover protocol. For example, if there is any a failure has been detected in the application component, it can switch over to the following things. That is, the secondary copy of the parallel thing can be promoted, and primary reconstitutions of the application's clients can be there, and secondary is started to serve the backup of the new primary one, and the newly started secondary announces to the new primary. So if there is any failure in the secondary copy, it can started with some other processor. This is known as code template. Next one is the process. In the code template, there is a code for every critical component which should be standby, and based on the application specific code, it fixes the template. So the advantage of this template is it is having the similar properties, and they need to be debugged, and the complicated portions of the template has to be completed by the skilled personnel, and it should be handed off to the less skilled personnel. Next one is the keeping the code architecture consistent. So the implementation will drift away from the documented architecture. So implementers may make decisions either whether it is not consistent, either it can be with the architecture. So this architecture may not be seen or foreseen all the eventualities that come up. Next one is the preventing the architecture erosion. Means the architecture is not consistent, how it can be prevented. By using some set of tools, architectural constraints, it can be prevented. And it can use some kinds of rules. Okay. And it can mark the documentation out of date when the erosion is occurs. And there can be the schedule for the documentation and the synchronization. Next one is the architecture and testing. There are four different things in this architecture and testing. First one is the unit test, second one is the integration test and the network effects, and the last one is the test activities. Unit test means it is going to be a set of components. It is going to be defined as the units. So this architecture defines the responsibilities and interaction of the units. So the test hardness will drive the element to be tested. So the test hardness test can be tested. Responsibilities of the functional correctness, performance through the synthetic loads, availability through fault injection, and modifiability requirements can also be tested, which is telling about each and every functional responsibility has to be corrected, and the number of loads could have been verified through the performance, and if there is any fault, what is the next availability for it and how can be modified. So these are the things which is going to be done in the unit test. And in the integration test, it is going to test the functionality, performance, availability and security. Security can be tested by using various attacking scenarios, and the system may degrade being run for a long time if the resources are not freed, configuration incorrectly specified. Okay, that can be specified through the availability of the resources. Network effects. Suppose if the system is having the error, it may go to the performance degradation. So this is with the normal variation will using the server. So that time the server may degrade the process. Here the configuration errors are the common during the installation, which may lead to the network defects. So the routing the message through intermediator rather than the directly to introduce the latency. And the chapter 10 is deal about this testing techniques and running systems. Network effects is the best found through the self-aware systems. So system monitors itself make values available externally. Next one is the activities. So the activities involved in planning, development, interpretation, harness creation. So planning means the architects know sensitive areas of the system where the systems are having the important functionalities. That is only test planning. Development is telling about the increment of the system developed to satisfy the predetermined test. And interpretation is telling about various monitored values should be and how it can be equipped with the interpret test results. Next one is the test harness creation. So this is telling about intimately interact with the system and requires the architecture knowledge. So far what we studied the implementation and how the activities can be embedded with the software architecture knowledge, and how the templates can be used, and how the erosion of the architecture can be prevented using the tools and management process, how the testing should be conducted, and what is the unit and integration test of the architectural knowledge, and what is the network effects and the architecture load involved in a variety of test activities. So these are the things we studied today. So with this our class is over today. The remaining we will see in the next class. Thank you.